All right, so we have the half-life of carbon-14 is 5,600 years. From a sample of 268 grams of carbon-14, how much will be left after 400 years? So we want to ultimately figure out what do we get when we plug in 400 into our growth decay equation. In this case, we have decay. So let's write down our equation. A of t is equal to a sub 0 times e to the kt. And in this case, we want to figure out a of 400. Initially, we have 268 grams in our sample. And we don't know k, unfortunately. We do know t. We know t. We want to know how much will be left after 400 years. But we don't know k in this case. So first things first on this problem, we need to first find k. There's no way we're going to be able to answer the question unless we find k first. So let's see here. Let's go ahead and do that instead. So we do know the half-life of this carbon-14 is 5,600 years. And so what that actually means is after 5,600 years, we can expect to have exactly half of however much we started with. So here e to the kt, t is 5,600. So since we can expect to have half of what we started with, well, in this case we start with 268 grams, so half of that is 134 grams. That's how much is going to be left after 5,600 years. And we can go ahead and divide both sides by 268. The nice thing here, whenever you have one of these half-life problems and you're trying to figure out k, well, 134 divided by 268, that's just 1/2. That's, the fact that we were using half-life there, we have exactly half of what we started with, so that ratio should always end up being 1/2. To get rid of the e, let's take natural log of both sides. And since the e is gone now, we can go ahead and divide both sides by 5,600 to get k by itself. And from my calculator, that ends up giving me a negative 0.0001 approximately for k there. And now since I know that, I can go ahead and plug it in for k in order to find a of 400. I got a negative there, which I should expect. We're half-life, we're having something, so we're decaying, we're getting smaller. So 268 e to the 400 times negative 0.0001. All right, and now that's a calculator problem there. We need to go ahead and plug that into our calculator. I got approximately 257.49 grams. Round to whatever my math lab wants you to round to there. But on these problems, unless you have k to begin with, you're gonna have to find it, whether you're explicitly asked to find it like we did on our growth problem, or whether we just figured out here, oh, we can't do this problem without k. That growth constant, whether it's growth or decay or whatever it might be, is very important to these problems. We can't really do much else without it. All right, we know a certain radioactive isotope decays at a rate of 0.157%, and we want to find the half-life of the isotope. All right, let's go ahead and set up our equation here. So A of t is equal to A of 0 e to the kt. All right, let's plug everything in here. I'll leave A of t alone for a second. A of 0, unfortunately, I do not know here, so I'm just going to leave that alone as well. E to the k, so k is 0.0015, if I go ahead and make that into a decimal from percent. Also, this is a decay problem, so I need to make this negative, and I have my t there. Now for A of t, I don't know how much I'm starting with, but I know this problem is asking me when will I have half of what I started with. So I can go ahead and divide both sides by A of 0. And that'll leave me with 0.5 on the left, e to the negative 0.00157t on the right. Take the natural log of both sides to get rid of the e. Leaves me with a negative 0.00157t on the right hand side. I can go ahead and divide both sides by negative 0.00157 to get t by itself. My calculator there gives me approximately 442 years there for t. Usually my lab will have you round to the nearest year on a problem like this.